Hello everybody, welcome to my class again. Before I start this class, I first like to wish you all Merry Christmas. So today we'll discuss further about the circular measure. So we have covered a lot of things in our previous class. So today I'm going to discuss that through how we can get the sine of the area of triangle. So first of all, we shall talk about how to find the area of triangle. So how to find the area of or triangle, I would say. So in general, the area of triangle is defined as half times of base into height. So for example, you are given a triangle like this. So say this is a triangle. So area of a triangle is defined as in general base into height. So say that its vertex name is A, here this is B, this is C, and then you can name this as D. And here we have dropped perpendicular from A to the base to the side BC. Perpendicular means this is the 90 degree, right? So in order to name the side of this triangle, so BC is the opposite side for A, so call BC as BC of length A and AC of length. You can call it opposite to the angle B, so it is B. And this is opposite to the angle C, so this side you can take as C. So in general, the area of triangle is found to be equal to half times of base BC and times height AD. And also the another formula that you know is this is S minus A, S minus B, S minus C. So all under the root. Yeah, and you know that S in this case is A plus B plus C divided by 2. Right, so this is also called the semi perimeter of this triangle. If you talk about, then it is triangle A, B, C. Okay, so these are the method that we calculate the area of triangle in general, and there are another method or formula that we can develop in order to find the area of this triangle that is going to be widely used in problem solving area. So you can write it here AC. So it is AD over AC. You can see the length of AC is B in this case. So it is B. That gives you AD equals to B sine C. Alright. So therefore from this part, if you would like to say that area of triangle ABC in this case, you know that this is half times of base. So base in this case is BC for angle C. So it has CD, but in the whole entire triangle base as BC. So you can write here BC and times the height of the triangle is exactly the perpendicular height. So it is AD. BC length is A, and AD we have found here as sine C. So eventually we have half AB sine C. Alright. What you can see here that this is area of triangle is also given by half times AB and sine angle between times sine angle between the sides of length A and B. You can see here this is angle C, that is sine C, and the angle C is between the side length A and B. So in this form we have got the area of triangle ABC in this case. And similarly here you see that AD equals to B sine C are given. So if you talk about sine B for example, so area of triangle ABC is half times of base BC. You can write here base BC times the perpendicular height is again here AD, so that you can write here AD, and equals to half BC side length is A again, so you can write here A, And from this part, you can substitute for AD. So AD equal to C sine B. Okay, this is half AC and sine of angle between the side length A and C. So you can see here that B is the angle between the side of lengths C and A. And similarly, if you drop a perpendicular from angle B onto this side AC, then you can suppose AC as base, and this sort of thing will be the perpendicular. So in that case, what you can take here that sine A angle, we have already talked about sine B, sine C and sine B. So let's talk about sine A. So sine A, in this case, we'll have again B by B. So for this angle sine A, this triangle, okay, so you can name this as B also. So in triangle BAE, sine A, for sine A, perpendicular is BE and the hypotenuse is AB and its length is C. In fact, so it is BE equals to C sine A. Okay, let's move further. If you would like to find the area of triangle ABC, so in that way, again you can say that half base into height. So base is at this time it is B and height is BE. So BE we have already obtained here. So this is C sine A. So you can again say that area of triangle is equal to half BC and sine of angle between the sides B and C. So you can see that angle A is between the side length B and C. So same area can be represented in this form like area of triangle ABC is also, this is half BC sine A. So if you talk about, this is formula 1 and this is formula 2 and this is formula 3, and these are all for the same triangle ABC. So therefore we can say that all these sorts of equations are the same. So eliminate the like things from all three sides here. So half, that means 1 by 2 we cancel out. So we are here that this is BC sine A equals to AC sine B. This is B equals to AB sine C. Next step, we divide all the sides by ABC. That we can do algebraically. So this is also divided by ABC and this is also divided by ABC. So you can see here that here the term BC and BC got cancelled out in the numerator and the denominator. Similarly, AC and A and C over here is cancelled out, and here it is AB and then AB are cancelled out from the numerator and denominator. So finally we are left with here sine A by A equals to sine B by, you can see here A and C are cancelled, so we are left with B here, sine B by B, and it is sine C by C. And if you reverse this ratio, in that case we have A by sine A equals to B by sine B equals to C by sine C. Alright, so I'm going to show you now how we apply this sort of thing to the problem area in general. Same thing has been summarized here. So you can have, look at this area of triangle, generally half base into height, these sort of things are given. So if you like, I'm moving forward this from this page, but if you like to see it carefully, you can pause your video over here and watch it until you understood it completely. You can see one example is that if these two sides are given, this angle is given, then you will be able to find the area of the given triangle ABC. And also, for example, if these two sides are given, these angles are given, these two angles, and this side are not given, in that case also you can further work out. So that is under this sort of topic. That is what other features that you can see here. That here we have the area of the triangle from the same triangle. I have used the ABC triangle is like this, and we have two objectives here, that how to get this angle A and C, and other objective is that to get the side length AC. So just have a look over here. You can see that ratio of sine A and sine C equals to 4/3. That you can also get the sine rule by applying the sine rule, and also by using the eta formula, that under the root S minus A times S minus B times S minus C. So we have already the values of two sides, that are C, and then you can see A, but we require for B. So we are working for B here. So after some algebraic simplifications, we have got the values of B in terms of positive and negative signs. So we have pair of values of B over here by using the sine rule. So here we are confident that this is A by sine A, because this side are given here. A by sine A, you can see that is 8, and for the C by sine and C by sine C, so we are also confident in these two values. But for this value AC, that we have got like, that is B, and B are these possibilities here. So here in this case, we take only the positive sign, because then cannot be negative unless otherwise stated. So here we are taking the place of B either 11.6 or 8.1. So by using 11.6, we have one value A and C, where B is already given there. For A, this is 0.698, so we put here 698. 1.2 is already given. By using the same value of B, 11.6, we have got the value of angle C as 0.503. You can see here the first value is for B equals to 11.6. In that case, we got the total value of the angle in the triangle. The sum of the angle is here in this case is 2.401, which is far less than the value of pi, which is roughly 3.14. But by using B equals to 8.1, when we have added all these angles, like here 1.16169, this is based on the value of B as 8.1, and C also we have obtained by using the same value 8.1. So these two are the values of angle A and C based on B equals to 8.1. And now we have these three angles, so we have added, although this is not exactly 3.14, but it's very close to that value of pi. Therefore, we can say that these angles are correct. Because I have already explained it before, so I'm just going forward to display this to you in order to hope that you will pause it here if you require extra time to have look at that. Otherwise, you can go ahead to see all these problems carefully. So this line AC and BC I have taken as the construction in order to solve the things in part B of this problem, where the problem was something like that. So in this case, the diagram shows the semicircle is 10 centimeter and center O. So this is the original figure, and it is said that the angle POC is theta, so obviously this side of the angle is going to be pi minus theta, because the straight line is 180 degrees, which is pi radius. This angle is pi minus theta. So this problem states that the perimeter of sector AOC, you can see that sector AOC is twice the perimeter of sector BOC. So this is the perimeter of sector BOC, and you know that these are given for the perimeter of this sector. You add all these boundaries for this sector. So these boundaries are AO, that is the radius of the circle, and OC, which is also the radius of the circle, that is 10. And then by using the S equals to R theta, you can get this value of this part of this figure. And then if you add up all these, you have the perimeter of this part of the circle. And similar thing you do here, and then you get the perimeter of this part, and then go according to the question that it says that the perimeter of sector AOC is twice the perimeter of sector BOC. That means you can write down perimeter of sector AOC equals to 2 times the perimeter of sector BOC. Replace that the term that we have derived for this sector AOC and also for sector UC. These things have been done here. So this is part B. So the part B, what you can do is that it has asked you to find the perimeter of the triangle. You can't see that triangle over here. So in that case, you can make one triangle beside this figure. So we start from here. Then join these two. And we made this triangle because it is asking you to find the perimeter of the triangle ABC. Now the triangle ABC is written over here. And by geometry, you know that this angle is 90 degrees. So this is a right angle triangle. So in the right angle triangle, this is 10 and this is also given 10. And these two sides are equal. That means these two angles are equal. Say this is x and this is x. As you are now from part A, value of pi minus theta is available. Just put theta value as pi minus 2 by 3. Calculate it. And then you'll have value of x because you add up all these angles equal to pi radian. Then you'll have the value of x. So if you take sine of this angle, then you'll have by sine b by s, that is bc by ab, which is 20 centimeters here. You'll have the value of bc. And similarly, same work if you do to the another side, you'll have the value of this angle once, or otherwise from the same triangle, same angle A. Once you use sine, and then another time you use cosine. So cosine is base by hypotenuse. So base is here in this case, but this angle is AC, and hypotenuse is 20 here. So you'll be able to get the value of AC. So as you have now value of AC, value of BC, and this is already now, it is already 10 plus 10 is 20. Then add up all these values, you'll have the value of the perimeter of this triangle ABC. So this sort of thing has been done here. This is another example you will have to get here. This is another problem. So this is all from my side. I'm going to hand it over. I'm going to hand over this class to Ankur, who will conduct the session for the presentation of problem solving by some of you in this class.
Good evening, everyone. So we're going to have this presentation on circular measure today. The presenters would be Tisa, Saujanya, and Vidita in that particular order. Tisa, okay, before we start the presentation, I'd request everyone to turn on their cameras so that your presence will be acknowledged by the presenters and will be motivated. They will also be motivated to present and make this class fruitful. Okay, so the first person presenting would be Tisa. And before Tisa presents again, everybody else, please keep yourself on mute. There will be time, if you have any questions, there will be time after the presenter has presented. So please save your questions for at the end of the presentation. All right, thank you. Tisa, the floor is yours.
Thank you. So I'll be sharing my screen. Is my screen visible?
Yeah.
Okay. So I'll be presenting question number 7. And the question is, the diagram shows a circle with center A and radius R. Diameter CAD and BAE are perpendicular to each other. A larger circle has center B and passes through C and D. So what we have to do is first show that the radius of the larger circle is R root 2 and find the area of the shaded region in terms of R. To solve the first question, I have let the radius of the larger circle be capital R, and then now in a right angle triangle BAC, as you can see in the figure, we will use the Pythagoras theorem and find the hypotenuse, which is BC. And we'll use the formula BC square equals to AC square plus BA square. and solve it to find r square equals to 2 small r square. And so solve it further to find capital R is equals to r root 2. So this is how we solve the first question. For the second question, which is to find the area of this shaded region, as we can see from the diagram, this shaded region, the area of the shaded region can be found by subtracting the this this crescent, which is CFD AC, from the semicircle CED, which can be seen in the figure. I've written it here. To find the area of this crescent CFDAC, again from the figure we can find it by subtracting this sector, this triangle CBD from the sector CBD. Okay, so first in triangle CBA, the small triangle CBA, we will find the angle CBA using tan. Angle CBA equals to perpendicular by base, which is AC by AB, and we solve it to get 1. So, and then solving it, we will find angle CBA is equals to pi by 4. From the figure, we can see that triangle CAB is congruent to triangle DAB. So angle CBA is equals to angle DBA. Hence, the total angle CBD will be equals to 2 times angle CBA, which is 2 times pi by 4, should be equals to pi by angle. We can find the area of the crescent by subtracting the area of the sector, which is 1 by 2 capital R squared into pi by 4 minus the area of the triangle CBD, which we found using solving that like so. We found that the area of the crescent is pi r squared by 2 minus r squared. Finally, the area of the semicircle will be pi r squared by 2. And the area of the shaded region will be the area of this semicircle minus the area of the crescent, like so. And then solving it, we find that the area of the shaded region is r squared. Thank you.
We'll pause here if you like. Until you understood it properly.
Thank you so much, teacher. That was a lovely presentation. Does anybody have any questions for Tisa? If there are any questions, then you can type it or just drop it in the chat. Alright. So I figured Tisa was excellent in her job and she presented it pretty well. So there were no questions. Alright. So moving on. Now we have Sauzanya.
Okay, so please tell me when you can see my screen in just a second.
Sure.
Yeah. Can you guys see my screen?
Yes.
Yeah, so this is the question. So I'll just read out the question. The diagram shows a square of side length 10 centimeters. So all the sides are 10 centimeters, and a quarter circle of radius, a circle of radius 10 centimeter is drawn from each vertex. So from each vertex we have a quarter circle. So made up of four. This figure is made up of four quarter circles from each vertex. So and yeah.
I'm sorry, I'll just cut you. So if you guys have any questions, if you forget it by the end of the presentation, you can just drop it in the chat section, but that will be entertained at the end of the presentation. So please do that. Thank you. So sorry.
Yeah. No problem. It's fine. So the question asked for us to find the exact area of the shaded region. So that's the center of this part. So in this figure, first we have to think about this area, right? So to find this area, what we need to do is to subtract the area of the whole entire circle except this part, right? Except the other part. Wait, I'll just make this clear just a second. Yeah, so except since we need this part, so except this part, so which is everything else from this figure, you have to subtract this from the entire circle in order to get this part. So to find the area of the remaining part from this circle, basically we just have to subtract to find this area. But from this figure we can see like everything is 10 centimeter, right? The sides of this square and the radius of the circle. So this part, the areas shaded in red are all equal in area, and the areas shaded in blue are equal in area. So that's the conclusion you can get from the question. So to find the area of the remaining part, first, if you can, like, if we make a triangle from this very point, the one I've highlighted right here, joining with the base of the square, so we'll get a triangle. So if you can notice, this will be an equilateral triangle, and for the reason being, for this sector of the circle, this will be its radius. So since the radius and sides are equal, this will be a right angle triangle. So this angle over here, and this angle over here, and almost like all the three angles will be 60 degrees, right? So area of this sector, this small sector, I'll just clear this things up. Area of this sector will be half radius times the radius times theta. So theta here will be 60 degrees, which is pi by 3 in terms of radian. So moving on to, so we find the area of this part. So what we have as of now is this angle right here is 60 degrees, and we have the area of this sector, right? So if we add, if we subtract the area of this sector with this triangle over here, we can find this small portion, right? So I'll just clear things up. Yeah. So this sector minus this triangle will give us this portion over here. So now what we have right now is area of this small portion, right? So this will be 1 by 2 r squared theta from r squared theta. This was the area of this sector, right? So subtracting the area of an equilateral triangle, so area of equilateral triangle is with 3 by 4 a square, and where a is radius over here, so we'll just use r for now. So this will be area of the small portion over here. So now we find area of this entire portion over here. I'll just change color so it will be clear. Yeah. So this portion over here. So we find this portion over here. Right? So why do we do this? So if you can see, if you complete this sector, this part will be left out, right? And this part is, there are exactly four similar parts. So if you can see, like if you remove this area over here, will be left out with this. So there are exactly four. So in this figure, you can see there are four. So this two, this two, this two, and this two, right? So now what we can do is Now since we have the area of this small portion and this sector, right? So if we add this area, we'll find the area of this this entire portion. So what we have now will be area of this part, and if we subtract it with the sector, this sector, I'll just change color so it'll be clear. Yeah. So if we subtract the area of this sector with this portion over here, we'll be left out with this small part. So this small part is equal to this, is same as this part. So since there are 4, if you multiply that area with 4, we'll be left out with everything except the center part. So what's this? So basically it's, since this is 90 degree, that's pi by 2 as theta. So area of that sector will be 1 by 2 r square, and theta will be 90, that's pi by 2. So this minus the area of this. So for this, we can just write it down. Yeah, so area of that will be 1 by 2 r square theta, which was 60 degree for just this part of the sector, which is pi by 3, plus this equation that we just formed. So that's, I'll just move everything. Sorry. Yeah, so this plus this area, right? So this was 1 by 2 r square pi by 3. That's area of the sector minus the area of the equilateral triangle, which is 3 by 4 r square. So if we equate this, what we will get is root 3 by 4. We'll get, 1 by 3 pi r square minus root 3 by 4 r square. So now this is the area of this part of the triangle, the shaded region in this figure, right? So now if we subtract it with the sector, this this big sector, then you will get this area, if that makes it clear. So area of the whole sector is 1 by 2 r square, and since this is a square, that's 90 degrees, pi by 2, we'll just subtract this whole equation with the area of the sector, which leaves us with just the area of this part. So if we equate this, what you will get is, just 1 second. Yeah. So I'll not equate this step by step because it will take time. So what you end up with is root 3 by 4 r square minus pi r square by 12. This is just solving this equation. So basically we have got this area, right? So now if you can look at from this figure, there are 4 equal parts. So 1, 2, 3, 4. So if you multiply this by 4, then we'll have the area, this entire area. So everything shaded in this figure, right? So this equation gives us the area of everything shaded in this figure. So to find the center area, now everything that's left is just finding the area of circle. A square, that's L square, so basically R square, minus the area of the shaded region, right? So what we ended up from this shaded, this equation was 4 cancels out. So 4, this will be 3. So that's root 3 r square minus 3 r square. Pi by 3 r square. So putting that in this equation to find the final area, would just have r square minus 3 r square minus pi by 3 r square. So from the given in the question we have r, that's 10 centimeters. So if we put that in, 10 squared minus root 3 10 squared minus pi by 3 10 squared, you will get the area of just this portion, the kind of curvy diamond shape. So that will give you 31.5. So yeah, that's the area. So if you have any questions, please ask. Else, Ankur, you can take up from here. Thank you.
This is a summary of work that has been presented by Sozamir. If you require more time, you may pause here and have a look.
Thank you, Saujanya. I don't see any questions in the chat box, so we should assume that everybody got this pretty well. All right. Now next up is Vijayda.
Thank you. Just a second.
Sure.
Yeah, it's screen visible.
Yes.
Yes, yeah.
Okay, so this is exercise 4B, question number 10, and what we have to do in this question is find the length of this yellow line. You can see that is covering these two circles and also this part here. So first of all, this question might look very scary. So what we will do is simplify this into different parts and then manipulate this diagram in a way that it will be easier for us to solve and then find an approach to solving this. Okay, so what we can do first of all is, in that question, if we see this is a bigger circle, this is a smaller circle comparatively, and then there's a line that's running through like this, the whole circumference, and then there are straight lines here, right? So even though the question gives this x and y there as extra, what we can do is take it in a way that it's easier for us. Now we know that if we consider this as a street. Also, if you guys get confused in the middle, you may interrupt me because I don't really mind. Okay, so yeah, this we understand is a line running. We are given that these two are centers. Okay, so let's just look at this line first. We can call this a tangent to both these circles, and then this is a line running from the center. So we can say this will be perpendicular, right? Also we can say this will be perpendicular. In similar way, we can say this will be perpendicular and also this will be perpendicular. Then we join all that and also we join these two centers just so that it gets simpler for us. Now, what we get after doing all that is this shape, right? So let's just do this shape, right? This laptop kind of shape. But what is the use of that shape? We don't get anything. Neither can we find this length, nor can we find this, neither this. So it doesn't really help. So what we do is we add two more lines, this and this, both of which we construct to be perpendicular to these radiuses, radii. Okay. So now after we've made this perpendicular to this, what we can say is this shape here is a rectangle. Okay. Similarly, this shape here is a rectangle, and this shape here is a right angle triangle. This shape here is a right angle triangle. Okay. One more thing we can conclude from here is this right angle triangle is exactly identical to this right angle triangle. Okay. And since we constructed this line, we can simply call this angle theta. Doesn't really matter. Okay. Now, what we are given is this radius to be x, this radius to be y. And we constructed this angle as theta.
we need right now, what we're trying to do is find z. Okay, and maybe this z, or it's the same thing because it's a rectangle. So this z equals this z equals this z equals this z. So any one z, if we find this length. Okay, and you understand why we're trying to find this length, right? Because we need the whole length. So first we're trying to find this length and this length, and then we will add it to these two lengths and then find the total thing. Okay, so now for z, what we do is, if we look at, let's look at this triangle here. Okay, now if we look at that triangle, how do we get x minus y and x plus y to be the sides of the triangle? We can see if this is x, then this is also x. If this is y, then this is also y. So this whole line here will be x plus y. And if this is x and you subtract y from here, then this part will be x minus y. Right? You get this, right? This whole thing is x, this thing is y. So if you subtract, you get this portion to be x minus y. And we said that these two triangles are identical. So if this is x minus y, then this is also x minus y. Okay, and this thing is x plus y. Now to find this, we can simply use, and we know this is a right angle triangle. So to find this, we can simply use z is equal to, z squared is equal to under root x minus y squared, x plus y squared. Okay. Now, what we need are these two curves. Okay, this here, this here. Now, if we look at it very carefully, then we can see this thing is a sector of this big circle. Okay. Now to find, and we can see this is an arc length of this sector, right? We have the radius as x, and we have theta. Now, how did we get this theta? How did we get this theta? We understand. Now we have this line. We simply have to add. We understand that these two are arc lengths, and that we will add all of them. But how do we know this theta? Okay. For that, let's look into the solution. Here, that whole thing, this whole thing is a reflex angle, right? 360 degrees. In terms of pi, that will be 2 pi, because 1 pi 180 degrees. In similar way, here also, this whole thing is 360 degrees. Okay. So what we do is, to find that, just that portion, just that angle, out of 360, we subtract angles on the remaining from like this angle and this angle. We will subtract.
Zoom that text a bit more, okay?
Okay. Yeah.
Go to the text, then you have to zoom it a bit. Yeah.
So from this whole angle, we are trying to subtract this and this. Okay. So how do we know this? We understand this is a triangle in which this angle is theta and this angle is 90. So what should this be? 90 minus theta, right? And if this is 90 minus theta, this is also 90 minus theta. Okay. So this comes out to be pi minus after subtracting 360 minus this angle plus this angle. Okay. Now, if this is clear enough, then this should be intuitive. This is basically again the same thing. This is 360 degree, and here it's even simpler because this is theta, and then you subtract these two thetas and then these two angles that are remaining. Okay. So when you do that, if you now you can, I think if you look into the solution, you'll understand. First, for the solution, we did for straight lines, we did Pythagoras theorem as we just discussed. The same thing here. Then for trigonometrical ratios, we found out the theta in terms of x and y, because we also have to keep in mind that we need to bring the answer in a way that is presented in the question, right? So we will find out everything in a way that will help us prove it in the end, right? So we find theta like this in terms of x and y, and then for that arc length, here we use this angle, and then here we simply multiply, nothing more. Here also, once you know the angle, you simply have to multiply. This radius will be x because this was this left, right, I don't know, blue arc, and this is green arc. And then in the end, all we have to do is add these lengths. Now why 2 and 2? Because we know that there were two straight lines, one up there and then down, it was like this, right? So for those two lengths, we multiplied the length by 2, and then we simply added the length of the arcs, and then total will be this length. So if it was too much to take at the time, find the length of this line, this arc length, and add it up. Okay?
So you found the perimeter, yes?
Yes, sir. Any question? Anything unclear? Anything? Why this perpendicular? How this was x minus y? How this was x y? Why this is y minus 2 theta? Anything? Okay. I think it's a no. I think that's it.
This is the summary of the work by Vijayata. I think we will have a look at this picture and then go to the first page. You may pause if you like.
So we're going to do a question on circular measure. The question is that the diagram shows a sector AOB of a circle with center O, radius big R centimeter, and sector angle pi by 3 radians. An inner circle of radius small r centimeter touches the three sides of the sector. Show that big R equals to small 3r. Show that the area of inner circle by area of sector equals to 2 by 3. So as you can see, we are given sector AOB, which has the radius big R centimeter, and inside the sector AOB there is a small inner circle which has the radius small r centimeter. And as you can see, the small circle touches the sector AOB at 3 points. And to make it clearer, I've given the center of the small circle the name C, and the points touching the sector AOB as D and E. And as you can see in this diagram, AO acts as a tangent to the inner circle, and OB acts as a tangent to the inner circle as well. So CE, which is a radius, is perpendicular to OB, as radius is perpendicular to tangent, and CR is perpendicular to OA. So if we draw a line passing through the center and O, it will bisect this angle, and it will create two right angle triangles for us. And if we take the right angle triangle CEO, as I have done here, you can see that the angle O has been divided into two. Therefore, pi by 3 radian has been divided by 2, which creates pi by 6, and angle COE will be pi by 6. And you can see CE is small r because it is the radius of the inner circle, and OC is big R minus small r. This is because in this diagram you can see that this whole line will be big R because it will be the radius of the sector AOB, which is big R. And in the circle, this line will be small r because it is the radius of the inner circle. And to get this line, which extends from O to C, we have to subtract big R minus small r. So you can see that I've taken sine O, which will be perpendicular by hypotenuse, and sine pi by 6 equals to CE by CO. Sine pi by 6 is sine 30 degrees, which will give R small r by big R minus R. And if we equate this, we will get big R equals to small 3r. Now for the second part of the question, which is area of inner circle by area of sector AOB equals to 2 by 3. So as you know, the area of a circle will be pi r squared, and area of sector AOB will be given by the formula half r squared theta, and as r radius will be big R, I've written here big R, and as theta will be pi by 3, I've written here pi by 3. And if you solve this, you will get 6 small r squared by big R squared. And as from the first part of the question, we've got that big R equals to small 3r. So So you substitute the value of big R here, and if you solve it, you will get 2 by 3, which will solve the second part of the question as well.
And this is the summary of the presentation by Pratishtha.
Thank you, Vijeta. Thank you so much, all the presenters. I guess pretty much got to internalize it better coming from our friends, from our peers. So peer learning is an excellent way to go about classes and to grasp concepts. Thank you so much. Thanks for watching.
Thank you everyone for your patience. We hope that you understood and got something out of this lesson. And
Hello everybody, welcome to my class again. So before I start my class, I would like to wish you all a happy Vijayadashmi, Deepavali, Tihar and Chhath Puja. So today we are going to start circular measure and probably will in that also. And in the circular measure, you will understand the definition of radian. So in this class, you will learn how to understand the definition of a radian and use of the relationship between radians and degrees. Then you will use the formula S equals to R theta and area equals to, that means area of sector equals to half R squared theta to solve problems concerning the arc length and sector of a circle. So let's go to the screen share now. So here in circular measure, you learn how to understand the definition of a radian and use of the relationship between radians and degrees. Then use the formula S equals to R theta and area equals to half R squared theta to solve problems concerning the arc length and sector area of a circle. So you can see here, this is about radian. So what is called the radian? Exactly that. You can see that this is a circle and the whole circle is of 360 degree or its measure is 2 pi radian. You know that. And then let's suppose that we got an arc length from A to B. Then the area inside the circle AOB is called the sector of the circle. And another fact is that if you have got this arc of length equal to the radius of the circle, and then in that case the angle subtended center has been taken as 1 radian. So this defines the 1 radian angle. So condition is that radius of the circle and the length of this arc AB in this case, if these two are equals, then a sort of angle will be subtended at the center, and that angle has been measured as 1 radian, and this is called the 1 radian angle. Now another fact is that you can convert from degrees to radians. So if the angle is given in degrees, you can convert that into radian, or the angle is given in radian, you can convert that into degrees. So here in this case, you have to understand that 1 degrees equals to pi radian. So the relation between degrees measure of angle and the circular measure of angle, also called the radian measure of angle, is that 180 degrees equals to pi radian. So for example, if you like to convert 45 degrees to the radian measure, we have now 180 degrees equals to pi radian. So unless otherwise stated, if you write pi, that means pi radian. By unitary it is 1 degree equals to pi divided by 180 radian. So therefore 45 degrees equals to pi divided by 180 times 45 radian. And when you solve it, it's going to be 45 ones and 55 fours. So that is pi by 4 radian. So in this way, we can convert the degree into radians. Here in this case, 45 degrees equals to pi by 4 radians. So in general, for example, if it is written pi by 4 only, pi by 2, pi, or the angle measure, then you always understand that these sort of things are in radians. So what did we do in this case is that in order to convert degrees into radian, we have multiplied the given degrees by 45 by pi by 180 degrees. So therefore, in general, what you can do is, for example, if you are just to convert 60 degree into the radian, what you can do here, you can write down 60 and then times pi by 180, then this value will be in radian. So after solving it, 60 degrees equals to pi by 3 radian. In this way, you can convert given degree into radians. Pi radian equals to 180 degrees. So by using the unitary method, 1 radian equal to 180 by pi degrees. Therefore, as you are going to convert pi by 4 radian into degrees, so therefore pi by 4 radian equals to 180 divided by pi times pi by 4. So everything will be here in degrees. So pi and pi are cancelled out. Then you divide 180 by 4, it will be 45 degrees. So in this way, we can convert radian into degrees also. And for example, now what we have noticed here that in order to convert that radian into degrees, you multiply here in reverse way that 180 by pi. For example, if you like to convert, say, pi by 6 radian into degrees, then what you can do actually, you can just take pi by 6 and then times. See here that we are going to convert pi by 6 radian into degrees, so you just multiply by 180 and then divide by pi. Pi and pi have been cancelled out, and 6 ones and 6 3s are, so which is 30. So that is going to be equals to 30 degrees. So in this way, pi by 6 radian has now been converted into 30 degrees. Okay, now we have another example also. So in the joining figure, calculate the lengths of AB and AC and also find value of BAC in radian measure. So this is a very simple example that makes you entry into the problem solving area from the circular measure. In this case, you should be able to use your skill of trigonometric ratios in this triangle and also the Pythagoras theorem that states h square equals to, it states that h square, that is hypotenuse square, equals to perpendicular square and the base square. So if you are taking this angle pi by 6 for example, so for this angle pi by 6, BC is base, AB is perpendicular and AC is hypotenuse. And for this angle A, for example, if you like to say that this one is base, then AB is base, BC is perpendicular and AC is hypotenuse for this angle A. So in this way, you have to understand about the triangle, that how we can use the trigonometrical ratios as well as the Pythagoras theorem to this situation. So in this figure, you have to calculate the length of AB and AC. So how do we calculate length of AB first of all? So first of all, I'm concerned to find the length of AB in this case. In order to find the length of AB, you can just use length of AB. So we use tan of pi by 6 because it requires the ratio of B and this is defined as tan of that angle. C in this case. So tan pi by 6 equal to B by B. So here B means we have AB and B means we have BC, and then your AB value will be BC times tan pi by 6, and BC value is already here, that is given 5 centimeters, it is 5 times of tan pi by 6. You know that tan 30 degrees values, otherwise you go to the calculator, then calculate this. So it is 5 times. First of all, you have to keep your calculator in the radian mode in this case. In order to go to the radian mode, so first of all you put on shift and mode. So in the shift and mode, you can see that there are 1, 2, 3, 4, 5, 6, and up to 8 items are there. So under the heading of 4, I think, yes, under the heading of 4, you can see that there is radian. Just put 4 over here, then the calculator is now radian mode. And in the third item, you have seen that it is the degree. So it depends on what you would like to take in. Like the theta, if you would like to take theta in degree measure, put your calculator in degree mode. If you would like to have your angle measure in radian, then put your calculator in radian. So now it is 5 times of tan bracket pi by 6. So this is pi divided by 6, and put this bracket. My answer is here. My answer is 5 root 3 divided by 3, and the unit is here centimeter given, so you can write that 5 root 3 centimeter. In this way we can apply the skill of trigonometry in order to find the side of the triangle based on the other given information. Now it says that also find the values of BAC, means value of angle A in radian measure. So in order to do so, you have a different way to do that. Here you can see now both these informations are here now. So in this case, in order to find the angle A, we again use the trigonometric, the appropriate trigonometric ratio. So I'm using here tan A. So tan A is, all of you know that this is d by b again. Here that we have used it, but in this case, in this at this time, the position of B and B will be different. So for angle A, B is BC and B is A. B is A. Alright. So now it is BC length is, you can see here, this is 5 centimeter. Given BC, AB length is given as 5 root 3 by 3. So AB length is here 5 root 3 by 3. So that it is 5 times 3 over 5 root 3, and these two are cancelled now. So this is root 3. So value of root 3 is, I think, 1.71, something like that. So this is root 3 and ST then 1.73. So that value is 1.73205, and few more numbers after this. Therefore, your A will be tan inverse of 1.73205, and rest of the numbers, and then equals to, go to the calculator. So your root 3 value is already here. So what you can do in this case, because this is the radian measure, so you the radian mode, so you'll get the value of A in radian in this case. So shift tan, that means the tan inverse, and then the answer over there, and then in that case it is pi by 3. So that angle is pi by 3. So this angle is pi by 3 now. So now let's check it whether or not our calculation was correct. So sum of all these 3 angles must be 180 degree, that means pi. So let's check that whether or not that is there. In order to check it, so one angle is pi by 3, and then another angle, this is 90 degree here, that means pi by 2. So plus pi by 2, and then plus here it is pi by 6. So this is pi by 6, and then LCM is 6 over here. So 2 pi and 2 3 ja, so 3 pi, and then this is pi. So how many pi are there? 3 plus 2 plus 6 pi. So this is 6 pi by 6, and 6 and 6 got cancelled out, and then we are left with pi, which is true. Why it is true? The total sum of angle in a triangle is always pi radian or 180 degree. Also find the value of angle BAC. So we have already got the angle of value of angle A, that is angle BAC, as pi by 3. Now in radian measure. And now, for example, we have got the length AB, and also in order to find the length of AC, you can do it two ways. That one way you can apply the Pythagoras theorem, and then in another way you can again use the trigonometrical ratio. So you should know both the skills in order to go deep into the problem solving area. So here now, if I am finding the value of this AC, so firstly by using the Pythagoras theorem, value as 10 root 3 by 3 divided by 3. If you would like to convert that into some number correct to some significant figure, for example, to a significant figure, then you can write here like this. So after calculating this, then it will be 5.77 up to 3 significant figures. So unit is again here in centimeter. So this is one way that we calculate the length of side AC. There is also another way to calculate this by using the trigonometric ratio directly, like sine, cosine, and tangent. So you have to see that here. Actually, as you are going to find the value of AC, in fact, so if you take this angle as pi by 3 or this angle as pi by 6, both of this you can apply here. So this time I am taking here angle pi by 6. Angle pi by 6. Let's see for angle pi by 6, if I am using P by H, then I can get the value of AC. Or also if I use P by S, then again I can get the value of AC. At this time I am going to use P by H, and that is defined for sine of this given angle pi by 6, and this is now sine pi by 6 equals to P means here you can see that P is AB, and S means we have AC. So therefore our value is 10 root 3 by 3 again, that we have seen it by using the Pythagoras theorem. So it is 10 root 3 by 3. And if you like to convert that into some correct to the 3 or 4 significant figure as you require it, or as it is needed by the question, then you convert that into decimal form. Then it is 5.77 centimeter up to the 3 significant figure, or up to the decimal places. So if you change the method, if you change the course, the answer should not be changed. Okay, next we have now length of an arc. That means we discuss about relation between S, arc, and theta. So theta is the angle at the center of a circle of radius r, and S is the arc length. So for example, if you call it as A and this point as B, in that case you can take this as arc length. So here in this case, like here. So in this case, what is the relation between S, arc, and theta? In this case, you can see that one radian angle is defined at the center when the arc length is equal to the radius of the circle. So for example, can you consider if this angle would be 2 radian, for example, it is 2 radian, for example. What happens? This arc length will also get double. So let's see for example like this, okay, and then this angle is 2 radian, then you can see that this arc length is 2 times of arc. And similarly, for example, in the increasing order or decreasing order, so you can take if it is half of this 1 radian, that means it should be half like this. In that case, the value of your arc length will be r by 2. For example, suppose that instead of 1 radian, now your angle is, say this is 3 radian, for example, this angle is 3 radian, for example. In that case, what happens to the r? This length will also get increased by 3 times. So this arc length will be, the value of this will be 3r. When angle subtended at the center becomes 3 radian. So in general, for example, like instead of 1 radian angle, if it is theta radian angle, then this arc length will become times of or theta times of r. That means in general relation between s, r and theta equal to s equals to theta r, that is s equals to r theta. So it has become now one formula to find one of these informations based on given two information. So for example here, if r and theta are given, then you can find the value of s. If s and r given, then you can find the value of theta. And similarly, in order to find r, you must have known the value of s and theta. So here are some examples you can see here. So in example 1, you have to find s when r is given as 8 centimeter and theta is given as pi by 4 radian. So always note that the theta value must be in radian. So here theta must be in radian measure. Alright, so you cannot say theta in degrees unless otherwise stated. In general, theta is measured in radian. So just now we have developed this relationship between s, r and theta. So we have now s equals to r theta, and here the value of r is 8 and times the value of theta pi by 4, and then it is 4 ones and this is 4 twos. So value of s is 2 pi centimeter, or otherwise you take a calculator and then this is 2 times of pi means it is 2 pi or 6.83. So you can write this in 6.283. So this is 6.283 up to 3 decimal places. You can also convert that into the 1 decimal place or up to the 2 significant figures. So you can write 6.3 up to 2 significant figure, and the unit will be the centimeter itself, because this is also length. Alright, and then in question number 2 it says that, let's see here, this question number 2 you have theta equals to what when r equals to 10 centimeter and s in this case is given as 5 centimeter. R equals to s divided by theta, so s is 10 centimeter and theta is 1, and then it is 10 centimeter in hertz. What if it is given like this? For example, find. For example, you are given to find. So I'm just making some extension to this question. Like, for example, you are given to find r. For example, r equals to what when s is 20 centimeter and theta is 60 degrees. So in order to find, okay, so here we know that again s equals to r theta, but theta is given in degrees, so you must convert that into the radian first. So in order to convert that into radian means 60 divided by 60 times pi by 180, and then this is 1 and this is 3, so this value of theta is here pi by 3. Right, this is pi by 3. So you always get theta in radians. Now you need to find r, so therefore r equals to s by theta, and our s value is given as 20 and then divided by pi by 3, so this is now 60 by pi centimeter. Or you can use the calculator and divide 60 by pi and get the answer in the given significant figure. Okay, let's have over some of the applied questions here. So using the same relation between s, r and theta. So here this question states that the high school roller ferries will in the USA has a diameter of 158 meter. So diameter is given as 108.5 meter. Then we have to calculate the distance traveled by a capsule as the wheel rotates through pi by 6 radian. Whether or not it is asked you to draw the figure or diagram, it's a good idea that you draw a diagram in order to visualize the situation so that your concept will be clear and hence your work will also be easy. According to this is a roller ferris wheel. The USA has diameter is given as, so you have your diameter is given as like this. This is the diameter. Okay, Okay, now the wheel starts to rotate from here, for example, we say, and it reaches to here about the center. Then you have this sort of situation you have. Then let's see here, according to the question, it says that this angle is pi by 16 radians. So this is not necessarily that you will draw the theoretical scale. That is only for our reference. And so the high roller Ferris wheel, the USA, had a diameter of 158.5 meters. So D is given as 158.5 meter. So obviously the radius is d by 2 in this case. So you can write here 158.5 by 2 meter. Okay, angle theta is given as theta equals to pi by 16, and the question is asking you to find the distance traveled by a capsule as the wheel rotates through the angle pi by 16. So suppose that the wheel starting point is at here, you can say this is A and it reaches to B, so you need to find this distance S traveled by the wheel. So we know that now we have by the relation between S, R and theta, so S equals to R theta. But what you need to find actually in this case you need to find the distance AB, which is S equals to 1. So here you put the value of R, so value of R is 158.5 divided by 2 and theta value is pi by 16. Now capsule, when the wheel rotates through pi by 6. Okay, we shall now talk about this question, this example that also makes use of the relationship between S, R and theta, that is S equals to R theta. So let's read out this question first of all. So this question states that the circle has radius 7 centimeter and center O. So the radius of the circle is given as 7 centimeter with center O. And AB is a chord. So this AB, straight line AB is a chord, and angle AOP is 2 radian. So this angle is given 2 radian at the center. Find the length of arc AB. Then arc AB means you have to find this length. So question number A, you can see that here you are given with R equals to 7 centimeter and theta is given as theta equals to 2 radian, and then you have to find the arc length, the length of arc AB. Question number A. So length of arc AB equals to what? So in fact this AB is S, and we know that S equals to R theta. So R value is given here 7 and times theta value is here 2, so it is 14. Therefore your arc length in this case is 14 centimeter. So this is the answer for question number A. Now you can see in the question number B that you have to find the length of this chord. So this is a bit tricky. Here you require some geometrical skill, and also if needed you require some trigonometrical skill. But in this case I think, let's see here first of all. So do you remember the theorems in circles? Like there are a lot of theorems in circles and triangle that we have already done grade 9 and 10. Also in your IGCSE, this is the center, and when you drop a perpendicular over this chord AB, then what happens here? What is the property in that case? This chord will bisect this angle. That means if this is 2 radian, it will become 1 radian from this side, and from another side also this is 1 radian. So this is one of the feature of this geometrical shape. Now another feature is that when you draw perpendicular from center to this chord, this will be the midpoint. That means this point it will divide AB exactly into half. Okay, so this is the another feature. And the third feature, if you like to discuss about, that angle at this point will be 90 degrees. That means this line divides the chord perpendicular at point M. And then another feature again of this triangle is that this is the radius and this is also the radius of the same circle. That's why these two are equal. So as in triangle OAB, these two sides are equal. This triangle is isosceles triangle. And now let's proceed further and find the value of the chord. AB. So chord AB equals to what in this case? Triangle MOB, you require the side length MB, for example. So MB means the sine of angle half O, because due to this line the 2 radian angle has now been divided into equal halves. Therefore one side is half of O. That is, when it was 2 radian, now it is 1 radian angle. So we can write here angle O by 2. So we are talking of this angle. And you know that sine of any angle is defined as the ratio of B and X. So in this case, you can see that for this angle, P is BM, P is BM, and H is this radius value. So radius value is already here, 7. So now it is sine angle O means angle O by 2 means here. This is 2 radian, which was already given. So divided by 2 equals to 1 radian now. So this is 1 radian equals to BM by 7. Therefore, the side BM is, it will give you the side BM equals to 7 times of sine 1 radian, and then using the calculator 9 and few more values after this, and if you round this up to the 3 significant figure, it will be 11.8 centimeter. Okay, so we answered question number B now. Now in question number C, it says that the perimeter of the shaded segment. So perimeter of the shaded segment means we are talking of this segment. This is the shaded segment. So perimeter, do you know what is called the perimeter? Perimeter is the sum of length of the outer boundary of a closed figure. So here the perimeter will be, so you can see that length of RKB is 14 centimeter, and then plus length of this chord is 11.8 centimeter. So total is 25.8 centimeter. So we also answered the question number C from this exam. Let's now talk about area of a sector, the given circle. Okay, so here this is sector AOB, where O is the center of the circle, this radius R, and the theta is the angle subtended by this arc length at the center of the circle O. So here in this case we know that area. So here we know that area of circle is pi r square. So we can apply this sense that, and the total angle at the center is 2 pi. Angle is 2 pi. Area is pi r square. This is the angle. So angle at the center is 2 pi means whole circle has total angle of 2 pi at the center. So when a point completes angle 2 pi, that is 360 degree, it makes a complete circle. So that we can say that if the angle is 2 pi, the area is pi r square. If the angle is 1 radian, for example, then by using the unitary method, the area of that part will become pi r squared by 2 pi. Therefore, as this angle is theta, so if the angle is theta radian at this center, then area becomes pi r squared by 2 pi times theta. Now cancel the like terms. So here pi and pi have been cancelled out now. So that is equals to half r squared theta. So theta is the angle that makes a sector of the circle AOB. Therefore, this sort of area that we obtain here is the area of this sector. So therefore, you can say that the area of the sector, in this case, the sector is AOB, is now half r squared theta. So this is the general formula that we use in order to find the area of a sector of a circle when r and theta are given. So we now have area of the sector as half r squared theta. So we can apply this to the formula problem here now. So here, this case, this problem says that find the area of a sector of a circle with radius 9 centimeter. So R is given as 9 centimeter and angle pi by 6. So theta is given as pi by 6. So note that always theta is given in terms of radian. Then find the area means A equals to what? So area of this circle where theta is the angle at the center of the circle that subtends an arc of length S. So here we know that now. So here we know that area of the sector is half r squared theta. Now put all these values that we are available with. So this is half times of r squared means this is 9 squared, and then this is theta means this is pi by 6. Now calculate it. So it is 1 by 2 times of 9 squared is 9 times 9, and then 6 times pi by 6. 3 3s are 9 and 3 to the 6. So after multiplication it is 9 3s are 27 pi, and then divided by it is 2 to the 4. And your question says that give your answer in terms of pi. So this is the answer in terms of pi. Otherwise you take a calculator and then this value correct to required significant figure. Okay, so in this way we apply this formula to the problem A. So let's now discuss sine rule. So what is the sine rule? Is going to be highly applicable in the problem area that includes circular base. So first of all, let's discuss our sine rule. So this is any triangle ABC, and then sine rule actually defines like this. You can see here. At last is the relation between sine and their corresponding opposite angles are there. In that case, you can see that the relation is like this: A by sine A, B by sine B, and C by sine C. So in order to say the length of BC, so we name the length of this side according to the name of the opposite angle. So the opposite angle is A in this case, so we write length of side BC as A. Similarly, length of AC, which is the opposite side of this angle B, so we express AC by a small letter B, and similarly opposite to angle C is this length AB, so we denote this length of side AB by a small letter C. Okay, now so here is a triangle, and here we make some construction inside the triangle. So we are taking triangle ABD, so ABD. So our first construction is like this. We are taking this sort of triangle first of all by making our construction BD perpendicular to the side AC at D. So for angle A, if I am talking, so for angle A, if I am talking, then what happens here? For angle A, this is the perpendicular in a small triangle ABD. Inside this, that is due to our construction where we drawn the perpendicular from B to D on the line AC. Okay, so in this triangle actually for this angle A, BD is B, AB is perpendicular, and AD is the base for this angle A. I'm talking this angle A. So your sine A in general is B by S. So you can see here B means BD and H is AB, that means it is C. Therefore BD equals to C sine C after cross multiplication or after transposing this to the left side. And then we shall talk about another triangle towards other side of this triangle, small triangle. So we divided the whole triangle into two parts by the perpendicular line BD. So I am now talking of this outside triangle. So in this triangle I am talking of now angle sine C. So this is, I am talking of this angle sine C, this angle. So sine C means for this angle C, CD is the base, BD is again the perpendicular, and BC is the hypotenuse for this angle C in the right angle triangle BDC. So if I am going to find the ratio for sine C is defined as B by X. So for this angle C, B is BD again. So you can write here BD, and H is BC here. So in place of BC, you can write A because this side length has the name after its opposite angle, capital A. Again by simplification, BD equals to now A times of sine C. So from 1 and 2, you can see that BD equal to C sine A, and also in 2 it is BD equals to A sine C. So C sine A and A sine C are equal. So from equation 1 and 2, these two terms are equal, and after the cross multiplication, we can write here A by sine A and C by sine C. And now similar work we'll do in another way in order to find the other angles in relation to these two angles, or one of these two angles that we have obtained through the construction BT. Now we have construction CE, and we proceed in the further way. So we are taking this triangle now. So we have equation B now. Now we have to combine these two equations. So from A we have A sine A divided by sine A equals to C divided by sine C. But from B, A by sine A equals to also B by sine A. So equals, we can write B by sine A by sine A equals to B by sine B. So we can also write A by sine A equals to B by sine B. So all these things are equivalent to each other. In fact, these are equal to each other. Therefore, we can write in an arranged way, so that we have A by sine A equals to B by sine B equals to C by sine C, and this sort of relationship between sine of the angle and their opposite sides are like this, and this sort of law or the relation is now called sine. So this sort of thing is going to be used widely and frequently in your problem A. Okay, we shall now see how the sine rules can be used in the problem area. So let's read out this problem first of all. So this problem states that the diagram shows a sector POR of a circle center O with radius 8 centimeter and sector angle pi by 3 radians. The lines OR and QR are perpendicular, and OPQ is a straight line. Find the exact area of the shaded region. So here in this question, you are given a triangle QOR. This sort of thing is the part of a circle with center O and radius 8 centimeter, called sector of that circle. So in fact, it is the part of some sort of circle having the radius 8 centimeter, and hence in this figure only the sector has been shown, but it means that there is entire circle. So you can use the property of entire circle as well whenever need here. So let's see that before going to solve the problem, if you understand the problem, you are more than halfway the solution. So here the diagram shows a sector POR of a circle. This center is given O. Its radius is 8 centimeter. Definitely the another side OP, this is also radius of the same circle. Therefore, this will be 8 centimeter. And sector angle pi by 3. So this sector angle is given as pi by 3 radians. The line OR and QR are perpendicular. So this is the line OR and this is the line QR, and this is given that this is perpendicular. That is, they make angle 90 degree at point R. That projects R. OPQ is a straight line. So OPQ is a straight line. Find the exact area of the shaded region. That means you have to find area of this shaded region. So before proceeding to the solution area, first of all, you have to make a mind map that how you can solve this problem. So here you are given this triangle, and some of the information about the triangle is also given, like this is 90 degree. This is a sector of a circle of radius 8 centimeter, and you are supposed to find the area of this shaded region. So what mind map you should make it that first of all you need to find the area of this triangle and then area of this sector. So from the entire triangle, if you deduct this area of the sector, you will be left with this area of this shaded region. Alright, that sort of thing will do that. So in order to do that, you have to deal with in two phases, one with the triangle and another with the area of this sector. So first of all, I am dealing with the area, dealing with this triangle OQR. So here in this triangle, I apply sine rule that defines this way: A by sine A, B by sine B, and C by sine C. And we have just seen earlier that what is the difference between the small a and the capital A. So if I'm applying the sine rule, then I work with the side QR, and then I work with the side OR, and then I work with the side OQ. So in this case, you can see that if you apply this sine rule over here, then what happens? Like QR, so this side is QR and its opposite angle is pi by 3 or O. You can write this is sine angle O. And OR, let's see here, OR, this length is 8 centimeter here. So it is OR. So OR is the opposite side of this angle Q here. So you can write here sine angle Q. And then OQ has opposite angle R. So you can write here sine R. And proceed to the another step now. So it will be QR by sine angle O is pi by 3. So you can write here sine pi by 3. And then it is OR. OR, you can see that either you leave it as it is, or you can see that OR as 8 centimeters. So you can write 8. And then sine angle Q. And then OQ. This side is OQ. So OQ you can write here. And then this is sine R. So angle R is 90 degree. That means this is pi by 2 radian. You know that this is QR, and QR by pi by 3 means this is sine 60 degree. That means it is root 3 by 2. And then OQ and sine 90 degree. You know that this value is 1. Sine 90 degree or sine pi by 2 radian value is 1. In this way, you can apply sine rule to a triangle. The same thing has been done here also. You can see. So in this case, same thing has been taken here. But what was the objective? That our objective was to relate side of one length to the other side of the given length. All right. So in that case, we have three things here: QR by sine pi by 3, QR by sine cube, and QR by sine pi by 2. So from first and last, it depends on how you are, in which direction you are taking your calculation. All right, or your derivation. So it depends on your concept that how you take the things while solving the problem. So in this case, I am taking first and last, and it is also possible that you can take second and last, and or first and second, depends on what sort of thing you need here. So here in this case, I am taking first and last. So first thing is that QR by sine pi by 2. So this is QR by root 3 by 2. And it equals to the last term is OQ by sine pi by 2, so it is OQ by 1. And now OQ equals to, we have 2 divided by, after reversing this fraction of this denominator, then it is 2 under root 2 divided by root 3, and times it is Q1. And now in the same triangle, you can see that, like you can apply Pythagoras theorem. So this is H, and then this is B. If you are taking this angle as reference angle pi by 3, and this sort of thing is B here. Alright, so Pythagoras theorem states that h squared equals to b squared plus q squared. Already you know that p squared plus b squared, and then in place of h squared you can write q squared equals to b squared, means you can write qr squared or q squared, and b squared means you can write qr squared. So same thing have been used here. Now in 2, you have already got OQ in terms of QR. So in place of OQ, you can put the QR value here from 2, and then it is 2 by root 3 times QR squared equals to QR squared plus OR is, you can see here in this figure here also that OR is 8 centimeter, because this is radius of the circle whose sector is given here. And then we will put here 8 squared, and after solving it, our calculation is like that, which is QR equals to 8 root 3. So we have now area of triangle as 32 root 3. Now area of the circle, you know that the area of a sector. Okay, so area of the sector is half r squared theta. So we can write here area of sector as half r squared theta. You can name the sector as QR, as it is given the reference points as center as at O, and its point are like POR. So P and R, so POR is the sector of the circle with radius 8 centimeter in this case. Just put the value of radius 8 centimeter 8. So here this is 8 square, and theta is the angle at the center is pi by 3. So we can put pi by 3 in place of theta. So we have now area of the sector as 32 pi by 3. And now therefore area of the shaded region equals to area of the whole triangle minus area of this sector POR. And then we put their respective values, like area of triangle QR is 32 root 3 minus area of sector POR is 32 pi by 3, and this is the answer. We have to give this answer in the exact form. As you can see that the question states that find the exact area of the shaded region. So we have to always write the answer this form unless otherwise stated. Okay guys, just like we did sine rule, and we saw also the application of the sine rule to the problem area. Cosine rule is also important to understand because this is also going to be widely used in the problem solving area of circular basin. So here in this case, suppose ABC is any triangle, and then sine rule we have already seen, but we'll see that how cosine rule defines in a given triangle. So in this case, let's consider ABC is a triangle, and we are concerned to find the terms this angle A, and you see that it is C has opposite side named C, A has opposite side named small a, and B has opposite side named small b that we have seen earlier. So simply this is a triangle, so we just draw a perpendicular line like this line as perpendicular to any of the side here AC. And if you like, you can also drop a line, start from the vertex A and drop down to BC perpendicularly at some point, and also you do the same work from C to the perpendicular, so from C to its opposite side AB. So at this time I'm taking the perpendicular line as by construction from vertex B to the side AC at M. So M is not the midpoint here. I will say that M is not necessarily the midpoint at this part. Now let's see here, if you apply sine C here for example. So in triangle BCM, if I'm taking angle C, so sine of angle C is, you know that sine of any angle is B by H. So B in this case is BM, and H in this case is, you can see that H is the side BC, and BC has length A. So first of all you write side BC, and then this is BM by BC as A. Your BM after the cross multiplication from this term to just sine C, it will be A sine C. So you can see here that this now BM equals to the side BM, this perpendicular side BM is A sine C. So you can put here A sine C. And similarly, in the same triangle, if you are going to take the cosine angle, so cos, so in this case you can see here that cos of angle C, the same angle I'm talking of, this angle C. So cos C is, you know that this is B by H, and B by H means B for this is MC, and H is again here, BC, so BC is A. That means MC equals to, you have A cos C. So you can see here for MC length, this is A cos C. You can take this length as A cos of angle C up to here. And we started from triangle from this side, and we'll associate the same thing the left side triangle also. Therefore this length we already have here, and this length is C, that is a small c. Alright, and then we require the length of this part of the triangle BAM. So what is the length of this part? Actually you can see here that A to C is the length B, and M to C is the length A cos C. So length for this is going to be actually whole thing B minus A cos C. So from B, if you deduct A cos C, then you have length of AM. So here you can see that the length of AM is B minus A cos C. So we have a lot of information in this triangle that will help us to deal further. So we have all the information from the triangle by using the sine ratio. triangle, like the part of the triangle BAM, you can take the part of the triangle BAM here. BAM, you apply the Pythagoras theorem, then it is h square equals to b square plus b square in place of h square h, which is ab, so you can write here ab square, and then perpendicular is bm, so you can write here bm square, and the base is am, so we write here am square. So ab square is c, so we write here c square, and bm we have found as a sine c, so we write a sine c square, and plus am we have got it from here that b minus a cos c, so we just replace c minus ab cos c. So what we have got from this derivation algebraically as well as geometrically, that's c square equals to a square plus b square minus 2ab cos c. So note that this CABR, the small letter, this ABC represent the side of the triangle, right? And you can see that this is cos C. So this cos C is the capital letter C that represents the angle C. So this is one of the cos rule, the cosine rule that we have seen here. And similarly, if you draw a perpendicular from B to M, I have done this, so you can draw perpendicular from this vertex C to this side of length the small c, and then you will have, and similar work if you repeat from A perpendicular to side BC, then you will have two more results like this. And here A is angle between B and C, and here you can see that AB cos C means, you can see here that C is the angle between the side of length A and B. So this is the way that we can remember this formula. So you don't need to mug up this. Just you try to understand yourself and practice yourself to get other sorts of formula by taking the perpendicular line from other vertices, and then once you do that, you will be able to induce that how to remember this formula. So this is not that difficult to remember. So these three formula are called the cosine rules. Okay, once we have learned about the cosine rule, now we'll apply that cosine rule to the problem area. And this example demonstrates that how we make use of cosine rule in order to find the solution of questions like this. So here in this question, it states that the diagram shows three touching circles with radii 6 cm, 4 cm, and 2 centimeters. Find the area of the shaded region. So here in this case, we can see that this is one circle and another circle, and this is the third circle. They touch each other at one point each. Alright. So in this situation, the radius of this big circle is given as 6 cm in this case, and for the medium circle is given as 4 cm, and the smallest circle has a radius 2 cm in this case. Alright, and in this situation you have to get the area of the shaded region that you can see it here. So here in this case, what you can do in your mind map is that you are given by taking the reference of ABC, you can have triangle, this is the figure, and then find the area of the shaded region. So you have to you are given only that this there are three circles. You can see this is a big circle, this is a medium circle, and this is the smallest circle, and they touch each other at points. You can name that point as C, D, E, or anything if you would like to write here as per your convenience. But the given situations are here that only the radii of the circles are given here. So radius of the circle, this big circle is 6 cm, and the smallest circle is 2 cm, and the medium circle has radius of length 4 cm here. And based on this information, you have to find the area of the shaded region in between the crossing point of all these three circles you can see here. So in this case, you have to think that first of all that how you can get the area of some of things. So if you consider radii of all the circles if they join together to make a triangle ABC, then you can think that you can find area of this triangle, or you can apply sine. these triangles or something like that. So one way you can think like that. And another thing is that if you can find area of sector, for example, area of sector of the circle with center B, and similarly for the circle with center C and A, then it will be possible to find the area of center in each circle. So once you find area of center, then from the whole triangle, if you deduct the area of all these, if you deduct all these sectoral areas, then you're left with this area of this shaded part. So in order to do so, what I'm taking here, I'm taking this section ABC is a triangle outside that was formed by joining the radii of each circle to each other. Okay, as only the radii are given but the angles are not given, that you require in order to find the area of the sector, because that formula is half r squared theta. In order to do so, we have to work for that how we can get the value of the value of each angle in this triangle ABC. So in order to do so, we have three cosine rule here that we first apply in angle C, or we can start with any, and in angle A and in angle B. So once we have the values of angles available, only then we will be able to find the area of sector. And once we have the area of sectors from each circle, then we deduct the total area of sectors from the entire area of this triangle. Will have area of this shaded region. So let's see that here it is done for you. That c square, you know that from the cosine, if you start with c square, then c square equals to a square plus b square minus 2ab, and cosine of angle between a and b, which is c, right? So by algebraic simplification, we have cos c equals to a square. So if you are taking c square equals to, for example, a square plus b square minus 2ab cos capital letter C, and then if you'd like to find cos C, then algebraically you can write here. Okay, so put all these values of a, b, c over here, then you will have the value of angle C. So here in this case, the value of angle C to obtain is by this method. If you put all these values over here, then it is cos inverse of 3 by 5. Take a calculator in radian mode, and then you can put cos inverse of 3 by 5, your value will be 0.927 radian. So we got this value as 0.927. So this value is 0.927. So this value is 0.92. Sorry, this value C is 0.927. And if you do the similar work with other cosine rule like a square, that's here b square equals to c square plus a square minus 2ca cos b, then cos this value of angle B has been found as 0.644 radian. So value of angle B is 0.644 radian. So always note that whenever you get the value of theta or any angle in circular measure, unless otherwise stated, these values should be in radian, not in degrees. And similarly, we have got the value of this angle as 90 degrees, that is pi by 2 radian. So now we have available all these three values of these angles. Then now we'll be able to find the area of this area of sector of each circle over here. So the total area of the sectors of the three circles is equal to half. This is given by the formula. You know that the area of the sector is area of sector formula is half r squared theta. So r square is available in this circle. So if I'm taking half r squared theta, then this circle has r value 6 and theta value 0.644. So you can see also that 0.644, this is the same triangle that I have taken out from this part of the circle. Similar thing you can apply to other circles, like you have taken the big circle here, then the medium circle has radius half r squared, is theta value is 0.927, that is angle 6, and in the smallest circle half required. So the smallest circle has radius 2 and the theta value is pi by 2. So we use base of r to base of theta pi by 2. And finally, after calculating this value, this is 22.15 centimeter. We need to find the area of triangle because we have already got the sum of areas of these sectors. Now we are interested to find the area of this triangle so that we'll have the area of this set region. So area of this whole triangle region will be given by this formula under the root s minus a, s minus b, s minus c. So s is the semi perimeter of the triangle, and then you put the values of a, b, c, and that s value is 12. And once you put all these values like values of x and values of a, b, c, you will have the area of triangle. This is also possible that to find area of triangle that because this angle is already, you can see that this is already a right angle triangle here. You can find the area of triangle by using half base times height formula. So in this case you can see that half and base is 90 degrees. So one of this is base is 6, and then its height you can suppose this as 8, 2 1 ja and 2 3 ja. So this is 20. So area of triangle is 24. You can find also by using the formula half base into height, or alternatively you can take area of triangle formula as s minus a, s minus b, s minus c under the root, and then this area has value 24 by this method also. So you can do in either way. So now we are available with the area of triangle as well as the total sum of areas of these sectors. So from the area of triangle you deduct the area of sectors, then you have the value of the area of this shaded region. So in this way we apply cosine rule and other geometrical and trigonometrical skill in order to solve the problem from circular measure. So if you like, then have a look for a while. Okay, this is all for now. Thank you for your patience.